You're given a palindrome string S and a number K and asked to find the kth smallest rearrangement of its letters that still reads as a palindrome when all such rearrangements are listed in alphabetical order. If the string can't be rearranged into that many distinct palindromes, you return an empty string instead. Intermediate level, you are about to solve a hard problem by writing half as much code. Build the left half correctly, mirror it, and you are done. By the end of this video, you will spot that shortcut in seconds. Think of this like sorting hotel rooms by rank without walking every hallway. That is what ranking permutations without generating them means. But there is one wrinkle. If a letter shows up an odd number of times, it cannot split evenly between the two mirrored halves. That one letter is the key piece we deal with next. Take Abba. Rearrange its letters so the result is still a palindrome and you only get two options, Abba and Bab. Sort those alphabetically and k equals 2. Just means pick the second one, Bab. You do not need to memorize these yet. You will see each one the moment it is used. A frequency jar counts each letter. Factorials count arrangements without ever generating them. And greedy picking chooses one letter at a time, like cracking a combination lock digit by digit. My first instinct, years ago, was to just generate every permutation and filter for palindromes. That works fine until S has 5000 characters and the permutation count explodes past anything a computer can hold. Here's the trick. Since the answer must mirror itself, you only ever decide the left half, then reflect it. Remember that sneaky character from earlier. That is the one letter with an odd count, and it has to sit alone in the middle. Every other letter gets split evenly between the left and right halves. So we only ever build a multiset half the size of S. Here is the click moment. This formula tells you exactly how many distinct arrangements a bag of letters can make, with 0 generating. So checking if k is too big becomes one division, not a giant loop building every option first. This is the same idea as counting in a strange number system, where each digit's place value is a factorial instead of a power of 10. For each slot we asked, if I place the smallest letter here, how many endings are still possible, and if k fits inside that range we commit to it. Otherwise we skip that many arrangements and try the next letter. The left half is built, so the rest writes itself. Middle character if there is one, then the half reversed. No extra counting, no extra checks. The palindrome shape guarantees it works. Clean. Try it yourself before the next slide. S is C Bab C and K is 2 what comes out. Remember, you only need to think about the left half. The half only has one B and one C, so there are just two possible halves, BC and CB, in that alphabetical order. K equals 2 lands on CB, mirror it around the middle A, and you get CBFC right back. In short, the kth palindrome is decided entirely by ranking that tiny half. You could import iter tools, generate every permutation, filter for palindromes, throw them in a set, and sort. It is dead simple to write and easy to trust on tiny inputs. Honestly though, this is the kind of code that survives an interview whiteboard and dies the moment a real 10,000 character string hits it. For just 10 characters, the brute force already checks over 3.5 million permutations, while the counting trick does a few hundred small checks. That gap only gets worse as the string grows. Pick the counting trick anytime the string can be more than a handful of characters, which, given the constraints here, is basically always. The total check up front catches k being too large before you waste any work building letters. A string like AA only ever has one arrangement, so k must be exactly 1, or you get nothing back. And since S is guaranteed palindromic, there is never more than one odd count letter to worry about. That part is handled for free. Remember that half problem I promised at the start? That is the whole solution. Build the left half with greedy factorial counting, then mirror it, and the hard problem becomes manageable. New daily drops tomorrow, same time. This algorithm took me years. A like and a follow take 1 second combined.